All right, welcome back. So today we are going to be continuing our conversation of graphs, and we're going to be talking about what's called the rate of change and also what is called slope. Now, you may have heard about these terms in previous years, and if so, great. If not, that's totally fine. We are going to be defining them and applying them to our algebraic ways of thinking. So without further ado, let's begin. So let's first talk about what's called the rate of change. So the rate of change is a ratio that compares the amount of change in a dependent variable, remember our y values are the dependent variable, to the amount of change in an independent variable. And the independent is going to be your x values. So we're comparing what happens with our y values to what happens with our x values. And we're going to be writing a ratio that compares our y value to our x value. Remember, the dependent variable depends on the independent variable. Your y values depend on your x values. So if we take this and put it into a real life application, the table shows the average retail price of peanut butter from 1986 to 1997. We're going to be finding the rate of change in cost for each time interval. During which time interval did the cost increase at the greatest rate? So we're given a table below. We have 5 different years: 1986, 1987, 1989, 1992, and 1997. Why they were increasing at those rates, I have no idea, but these are the years we are given. And then we're given the cost per pound: $1.60, $1.80, $1.81, $1.94, and $1.78. So we want to find the rate of change between these years. So the first thing we're going to do is we're going to identify the independent and the dependent variable. So this takes a little bit of thinking. You have to say, okay, what depends on which? 9 times out of 10, your cost is going to be the dependent variable. 9 times out of 10, your money is going to be your dependent variable. So if you ever see money, again, 90% of the time, that is going to be your dependent. Because it depends on how much is purchased, it depends on how much is sold, it depends on how much you buy, it depends on how much you sell, right? There's a lot of different dependencies that money has to it. So if our cost is dependent, that means the year is independent, because our year is going to change. That's naturally going to happen, and the year is going to continue to go on, even if there isn't a cost to it, right? So the years are going to continue to go on. That's independent of our cost, but our cost depends on our year. So now that we have our independent and dependent variables identified, the second step is we're going to find the rates of change. So to find the rate of change in every single scenario, we are going to find the cost, or the change in the cost in the numerator, over the change in years in the denominator, because it's the ratio from our dependent to independent. It's the ratio of our y to x. So it's going to be the change in y values in the numerator and the change in x values in the denominator. So as we go through an example, if we're looking from 1986 to 1987, the change in the cost, well, we end at $1.80. We started at $1.60. So we subtract them, we get 20 cents. We change the years. We ended in 1987. We started in 1986. We subtract them, we get 1. So we divide. So we get 0.2. And we continue this process all throughout our situation. Continue it all the way through the problem. And we want to identify what was the greatest rate of change. Through what years did our cost increase the most? Now notice, every single time we have our change in cost in the numerator, change in years in the denominator, because it's the change in our y values divided by the change in our x values. Now, another key part of this is when we look at the operations we're doing, when we look at these fractions, you're going to notice something. And let me grab out a highlighter real quick. Let's say 1986 is in yellow, 1987 is in green, 1989 is in blue, 1992 is in purple, and 1997 is just chilling. When we apply these values into our fractions, you're going to notice something here. Well, if we're looking from 1986 and 1987, 1987 is green. It was $1.80. 1986 is yellow. Notice how the green is on top of the green, the yellow is on top of the yellow. Looking from 1987 to 1989. Well, 1989 is our blue value. 87 is our green value. Notice green's on top of green, blue is on top of blue. And we continue this process all the way throughout. 92 was in purple. 89 I have as in blue. So you can see the purple is on top of the purple, the blue is on top of the blue. And now we have 1997 to 1992. Well, we said that 1997 for the color scheme of this is just going to be chilling. So if you notice, we have those values on top of each other. We have the year of 1987, and directly above it in the operation is going to be the cost in 1987. That's crucial. So we never want to flip-flop our values. We want to have what relates to each other above and below each other. So we wouldn't have a green in the upper left and a green in the bottom right. We have a green on the upper left, a green in the bottom left, a yellow in the upper right, a yellow in the bottom right. We have to have that consistency. That's going to be probably the most important part of when we are finding the rate of change, because that's really, really crucial for our next topic of slope. But before we get to slope, please work on problems 1 through 5 on your guided notes and jot down any questions that you have. Resume when you're ready to move forward. All right, if you listen to my voice, that means you have worked on problems 1 through 5, and you are ready to talk about slope. Slope, I love it. I love slope. I also love hitting the slopes, right? Have you ever heard that phrase before? Hitting the slopes? Like you're going skiing, you're going snowboarding, you're going sledding, right? You're going down a mountain, right? You're hitting the slopes. So that's somewhat of a connection to what we're going to be talking about when we have slope compared to a line. So when graphing rates of change, if all the segments have the same rate of change, same steepness, they form a straight line. That actually goes back to identifying linear functions. When we had tables and we were identifying that rate of change in our x and our y values, that's consistent. If it's consistent, it's linear. Well, hey, guess what? It's going to form a straight line. That's the connection there. We're identifying linear functions. We're now saying, hey, they're going to have a rate of change that's going to be a straight line. And we call this rate of change slope. So in order to find the slope of a line, because for right now we're going to be given a graph of a line and we need to figure out the rate of change, or specifically the slope of that line. So in order to do that, the first thing we need to do is choose any 2 points that are on the line. It could be any points on the line. We want to look for easy points to work with though. The biggest thing when you're looking at a graph, you want to make sure that they hit perfectly within the grid line if the coordinates are not given to you. So for example, if I am picking a coordinate point in quadrant 4, I want to find one that's perfectly intersecting that grid. I could choose that point. I could choose this point. I could choose that point. I could choose this point. Notice how they're perfectly intersecting the grid. But what we do not want to have is something that's going to be in the middle. That is not going to be easy for us to calculate because we can't really tell what that ordered pair is. If it's within the grid, if it's in that coordinate plane, it's going to be easier to tell what that ordered pair is, and we can make definitive statements like this one is 5, -1. This one is going to be 5, -5. This one will be 3, -3, and so on and so forth. We're able to make those connections. But if it's in the middle of our coordinate plane, we're not going to be able to definitively say what those 2 points are going to be. So please make sure that your ordered pairs are directly on the grid. Thank you. So after we choose those 2 points on the line, if they're not given to us already, we're going to begin at one of the points. We are going to be starting at a point. After we start at a point, we're going to count vertically until you are even with the second point. This is what we call the rise. If you go down, the rise will be negative. If you go up, the rise will be positive. And that should make some sense because we're going up and down, we're going vertical, we're going with the y-axis. And going up the y-axis is positive values. Going down the y-axis is going to be negative values. So if we're going up vertically, we're going positive. If we're going down vertically, we're going negative. After we do that, we're then going to count over until you are at the second point. This is what's called the run. If you go left, the run will be negative. If you go right, the run will be positive. And again, this should make sense because now we're looking at the x-axis direction. If we go to the left on the x-axis, that's our negative numbers. If we go to the right on the x-axis, that's our positive numbers. So if we're going left, it's negative. We're going right, it's positive. Here is a major Q-tip for you. And I'm going to try to jot it down for you too. Always go to the right. Whenever you can, try to always go to the right. It'll make it a heck of a lot easier to identify a positive and negative slope because we read a graph going from left to right. So if we're going to the right every single time, it's going to be much easier for us to identify a positive and a negative slope. So please, whenever possible, always go to the right-hand side. That way we're going in the positive x direction. Sure, there may be some times where we have to go to the left, but 99% of the time, again, we're going to always go to the right-hand side. And we'll talk about those specific cases a little bit later, but you always want to go to the right whenever possible. And now that you went up or down and you went to the right, you're now going to divide to find that slope. In our example, the rise was equal to -6. The run was equal to 2. So we divide it and simplify whenever we can. We can do -6 divided by 2, and that gives us -3. So the slope, or the rate of change, of this line is going to be -3. Remember, you always simplify your fractions whenever possible. Great job, folks. Please now work on problems 6 through 11 on your guided notes. Jot down any questions you have. Keep working hard. Super proud of you. I will see you soon. Have a good one.